Good morning. Let's consider a day in the life of a techie. During his busy work time, the best boost you can have is a cup of coffee. So, what makes this cup of coffee so special? It is a caffeine present. Caffeine is made up of different number of atoms arranged in a specific way. Caffeine molecule is complex than water but simpler than a protein. Say we want to understand this caffeine molecule fully, its structure, interaction, how the atoms are working together to make caffeine what it is, and how it stimulates us. But just the level of complexity involved with this calculation is beyond the power of any supercomputers that exist today. Why? Take a normal computer chip, add more and more number of transistors to it, make it really big, equivalent to the total number of atoms that make up our entire planet. But you'll fall short of explaining this caffeine molecule. Even if you keep going and going, make it equivalent to the entire number of atoms in the entire Milky Way galaxy, you'll still fall short of it. So your average cup of coffee beyond the power of the entire galaxy of computing scope. So what about these complex molecules which actually matters? Enzymes, viruses, proteins. As great as our computers are today, we are facing a fundamental limitation. There is a war. These very fundamental limitations opens up the doors to exciting opportunities. Now we are in a world where we hear about person-specific drugs, universal cancer cure, or stopping the epidemics. Our normal computers are not convenient for this. So we need a fundamental leap. We need process we have never seen before. We need a computing paradigm shift, and the solution is quantum processors, which uses the wacky laws of quantum mechanics. With regular computers, we process the information as zeros and ones, bits, basically like on and off switch. In quantum computers, the information can be zeros, ones, or it can be a superposition of zeros and 1. That is, it can have any value in between 0 and 1. These superposed states are called quantum states or qubits. So the main question is it possible to build a quantum computer? And surprisingly, the answer is yes. At an experimental level, quantum computers are already there. Although the preservation of these qubits require temperatures colder than the outer space, which is achieved through cryogenic cooling. So I'll say, we are a golden generation. We are becoming a part of revolution. We are becoming a quantum revolution that will change our future, that will change the computing world. Thank you.